Hi, I want to show that little proof here that I'm not going to tell you what I'm going to prove to start with, but we're going to go there. So we've got a pair of parallel lines, and first of all, let me switch over to my pen here. This angle, I'm going to label this 1, and we'll label this 2 and 3. So angle 1 is congruent to which angle? So angle 1 is congruent to angle 2 down here because they're alternate interior angles. And we've proven that in class that that is true. And I'm going to add another line. Oops, that didn't work. Oh, it's going to be a red line. I was not planning on that. Okay, so I've got another line. And so I'm going to label some more angles. And I'm going to label, let's see, we haven't done an angle 4, and an angle 5, and an angle 6, and I'm going to change colors too. So I want to know what is congruent to angle 4. So once again, kind of ignore the black line. On the red line here, we have alternate interior angles. And so 5 is congruent to 4. And so this is nothing new, but notice the figure I have in the middle. This is a triangle, right? So I'm going to, let's see, what haven't I used yet? I haven't used 7 yet. What do we know about 1, 7, and 4? What do 1, 7, and 4 have to add up to? So angle 1, angle 7, and angle 4 have to sum to 180 degrees because why? Because they're on a straight line. Now, if you said that they were supplementary, that's kind of true, but typically supplementary implies just 2 angles. They sum to 180 because they're 3 angles along one side of a straight line. Okay, this is a very rough proof. Okay, so 1, 7, and 4 do that. But we also know 1 and 3 and 5 and 4 are congruent. So let's just state that. You know, angle 1 is congruent to angle 3. And we know angle 4 is congruent to angle 5. And the reason we know that is because alternate interior angles are congruent when the lines are parallel. Okay, I'm going to state that. Alternate interior angles are congruent. All right, now, what do we know about the angles of a triangle? Do we know what they add up to? Well, some of you may already know, but this is kind of proof that they do, because look, 1 and 3 are the same, 4 and 5 are the same, which means essentially that if I do substitution and plug in angle 3 for angle 1, still got angle 7 up there, and I got angle 4, plug in angle 5, they must also sum to 180. And I'm going to be a little fast and loose, but I'm going to say by substitution. Okay. Now, that's going to be for all triangles. I didn't assign any values to these, but I'm going to real quickly, just so you can see. I'm just going to make up some numbers. I'm going to say, let me switch colors again. Let's do brown. Okay, so I'm going to say this looks like it's about 70 degrees, which means how big is 3? That's 70. And I'm going to say this is about, looks a little bigger. I'll call it 80 degrees. So how big is 5? That's right. Okay, so 70 and 80 add to 150. So how much does 7 have to be? Well, 7 has to be 30. And notice it's 30 and 70 and 80 also add up to 180. No matter what numbers I make up for this and this, doesn't matter what numbers, these two are going to be the same. And this is always going to be what's left over on a straight line. but then these are the same number, so it's going to add up to 180. So we know that triangles, angles, and it's really interior angles, sum to 180. It's a very fast and loose proof, but it's a nice way to show it. That's all. Thanks.